Hello and welcome to another BlenderWiz video. In this video we will cover how to use loops and functions. Functions and loops do many things to help us, including organizing code for ease of programming and minimizing code repetition, which keeps file sizes smaller. Let's begin with loops. A loop is a very useful structure for repeating a certain set of operations. A really good situation to use a loop is when asking a user for valid input. Within the loop, you can test if the user has given usable input or if they are just hitting random buttons. Instead of having a bunch of nested if statements, you can have a loop jump back to the top and ask them again, and again, and again, until eventually they give you a valid input. And then at that point you can break from the loop. There are two main groups of loops: the for loop and the while loop. Then there are some derivatives off of that. A for loop is generally used for when you know how many times you want to iterate through a set of code. Maybe you know that you have n integers in a list and you need to add one to each. The for loop will do a wonderful job of doing this. A while loop is generally used when you don't know how many times you'll need to iterate through the code. As stated above, a good example for a while loop would be taking input or even running the events in a game. Technically, either kind of loop can work in either situation and can be used interchangeably many times, but it is good to be able to use either. An example of when you should know how to use both would be in C. Even though we don't know how many iterations a loop is going to make in an infinite loop, a for loop implementation will work faster than the while loop implementation. This is because of the condition checking. The while loop will always come to the top and do a condition check, whereas the for loop will just run through forever and ever and ever, and it doesn't actually need a condition. We won't go too deep into these kinds of optimizations. It's something to be aware of for the future or for future use, and it is language specific. Python's kind of high level, and it probably optimizes most of this stuff out for us anyway, so don't worry about it too much. You should also be aware of the DoWhile loop. It's a derivative off of the while loop. Technically, this is the best kind of loop for getting input. Like a while loop, the DoWhile does well when you don't know how many times you will need to loop. The difference is where the condition is checked. On a DoWhile, the condition is checked at the bottom of the loop, or the looping code, instead of at the top. This means that the code inside the loop will always be evaluated at least once. Sadly, Python doesn't actually have an explicit DoWhile loop. What you do is create an infinite while loop, so while true, and have it check your conditions in an if statement at the very bottom of your code, or of what's in the loop. If the condition is not met, then break out of the loop and leave. This brings us into the last topic on loops: continue and break statements. Continue makes the loop start back at the very top on the next iteration without performing any more statements after that. In the example on the screen, I have the loop only print out even numbers by having the loop continue if the I variable is odd. This isn't the most efficient code, nor is it the best use of a continue statement, but it demonstrates how it works. The break statement stops the loop immediately. This is useful in many situations, but an easy example is when a user wants to leave that part of a program and not stop the program entirely, but anyway, the program is trying to get input. You can have an if statement in your input loop checking if the user has given a cancel entry, for example C, and if they have, break from the loop. Another useful situation would be reading parts of a file. For example, maybe you are looking for one piece of data that is in one line in a file, and once you find it, you don't actually need the file anymore and you don't need any more lines. So, one, you don't really want to leave the file open unnecessarily, because files are big, they take lots of memory, and they're just big. And two, you don't necessarily want to finish looping through the file because you've already found the piece of data that you want. And it's quite possible that this file has millions of lines, and maybe your piece of data is in the first line. You can break from the loop and close the file immediately instead of looping through all of the millions of lines and checking for data that you have actually already found. So in the example on the screen, I have opened some file F already somewhere off the screen, and then I go line by line and search for a string my data. If I find my data in the line, I set the data found flag to true, then break out of the loop so we don't go through any more lines. If the data is found, it prints out we have found the data and the entire line. If it doesn't find the data, well, it's going to have to go through each line anyway, and it won't say anything. A function is a statement, but it also contains a set of statements which are executed in a linear fashion. They are sometimes called subroutines. Generally, a function is good for performing a repetitive task. For example, if you want to get the sum of the numbers in a bunch of lists, one way to do it is to simply have a loop for every list, which goes through and adds each number to a sum and print it out or execute on that list, then do the next list. But it's much easier to write one function that does the sum operation on a list. Functions take a set of arguments or parameters, and then they may return a value out. Some functions don't actually have any arguments passed in and will only operate on global variables. This isn't actually a good idea because if, for example, you are using a variable with the same name, such as x, and the function uses x internally, you may find that it will result in a weird and unexpected behavior, or many unexpected behaviors. Using parameters separates the scope of the function from the program executing the function. In other words, a function is able to look at variables outside of the function, but an outside program or another outside function cannot look at the variables inside the function. It's kind of similar to a one-way mirror. There are also functions which don't return a value. We use these functions for their side effects. An example of some side effects are information being written to the console, data being written to the disk, or read from the disk, though not usually because you'd actually have to return a value there, or some in-place operations. In Python 3, a good example of a function which doesn't return anything is a print statement. Now, how do we actually create a function in Python? Well, it's pretty simple. We start with the keyword def, and then we write the function name, open parentheses, and then we write any parameters that we need passed in, and then close parentheses, followed by a colon to open up a new block. Then, using our rule of indentation for blocks, we can tell the computer what statements to execute as part of the function. In many other programming languages, if the function is going to return a value, we have to tell the system what type of variable it is going to be. Python doesn't actually require this, and this makes programming slightly easier. This is the difference actually between dynamic and static typing. In Python, some variable x can actually assume multiple different types, such as a string, and then it can be reassigned to an integer or a float, or really any kind of data. In Java or C, we have to actually define it ahead of time as an integer, or as a float, or as a string, and we can't actually go back and change it. Functions in Python must be given in order. If you wish to use a function within another function, it must have already been defined. Some languages actually allow you to define functions in any order you like, but it's easier for a programmer to read if the functions go in order from the simple functions at the top down to more complex functions at the bottom, and then the last function being the main function, which calls your entire program. This is similar kind of to how a novel goes. You start by introducing characters in their current dispositions, and then you build from there. The computer and other programmers are just reading your novel. Instead of being a good book, it might be a game or perform some complex calculations. It's generally good practice to have a function perform a single task instead of having many side effects. Since they really don't cost anything, it's good to write as many functions as you need instead of trying to cram everything into one. It is true, having the computer jump around in a program will actually slow it down a little bit, but Python was never actually designed to be fast. It's designed to be readable. And it's a lot easier to read a program with only a few lines of code that do exactly what is expected and specified in the function than have this mega function handling the entire program. Technically, there is one function though that does handle the entire program, and this is called main. So Python doesn't actually require a main function, but since so many other languages do require it, it is customary to have one in your program and have the entire program run out of main. Thank you for watching, and I hope you have enjoyed this lesson. If you did, please like it and subscribe. If not, please leave a comment letting me know what I can improve.